In this work, we introduced SmartBoxes, an interactive tool which enables a user to quickly assemble an architectural model directly over a 3D point cloud. The input data is a three-dimensional point cloud acquired from a LiDAR scanner mounted on a street-level vehicle. However, due to occlusions, many building parts are missing from the input, and in general, the obtained scans are typically quite noisy, with low resolutions, and outlier-ridden due to the presence of reflective objects such as windows and other glassy structures. Nevertheless, our reconstruction tool is designed to deal with such acquired data. From a typically poor scan shown here, the tool first reconstructs simple building blocks, which we call SmartBoxes, to form window railings and balconies through snapping and grouping. Next, one column is reconstructed through a drag and drop of the grouped compound balcony and window. Reconstruction of the whole facade is achieved in a matter of seconds by dragging the whole column grouped into a compound SmartBox and snapping to sparse regions. Note the irregularities in the scales of the columns and their spacing. As we show in here, sometimes the parts are not fully regular and the transformation between parts is not rigid. The assembly of SmartBoxes is through a discrete optimization to balance between two snapping forces defined respectively by a data fitting term and a contextual term, which together define the position of the boxes. Here we see the effects of the data fitting and contextual forces on reconstruction, where the compound balcony window SmartBox is dragged to snap to a noisy and sparse point cloud. This shows the effect of using the data fitting force only. Here the result of using the contextual force only. And finally, we show how the combination of the two forces work together so that inconsistencies in the data are disambiguated by the contextual force. In this session, we show an interaction of using cylindrical instances, what can be called smart cylinders. Note here how easily the user can reconstruct rather fine details. Our snapping operation automatically senses poor data quality or contextual irregularity during interactive reconstruction. It automatically adjusts the weights given to the two forces on the fly to optimally exploit these characteristics in available data. Here are some results obtained in sessions of less than an hour. Thank you for your attention.